Hey everybody, welcome back. Today I've got two rack units from the mid to late 80s that were sent in by a viewer of the channel. The first one is a reverb unit that we're going to look at today. That's what this video is about. And that is the Korg DRV-2000 reverb unit. And that's this one right here. And that's what we're going to fix today. And this has no power. It's been in storage for many years and may have been exposed to some moisture, so we'll have a look at that today. The other one is a Delta Lab ADM 1030. That's the Effectron 3. And this is similar to that Super Timeline video that I did a while back. So we already have a schematic for it, but we're not going to do that in this video. This video is going to be all about repairing the Korg. So let's get started with the Korg DRV-2000 repair. Alright guys, so let me just plug it in and let's see if it works. Yeah, I was told it doesn't power on, and I'll try it out right now and see what happens. Okay, it's plugged in. Let's turn it on. Nothing. Yep. Does not power on. Oh, wait. I saw something there. Saw a little flash of light here. Maybe not. Or maybe the switch is... I don't know. Oh, I just saw it again. There you go. Look at that. So when you power it off, you get a little light here. So right now it's on. Nothing's happening. Turn it off. Boop. Little light. Okay. It's probably a capacitor discharging or something. I don't know. Let's open it up and see what's inside. Alright, we got 8 screws. 2, 4, 6, 8. So let's unscrew them and take the cover off. Alright, there's actually 12 screws because you got the screws for the ears also. So, alright, so let's see what we got. Ooh. Yeah. Okay. Let's take a look. Hopefully there's nothing wrong with this transformer. That would be bad. Alright, let me check the fuses before we do anything else here. Let's see if those are good. Okay. That's good. 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 And good. So the fuses are all good. And just out of curiosity, see what the voltage is on this battery. It's dead. Yeah, it's dead. Alright, so this is a lithium cell. And I could tell it's dead because it's a little bit bloated. Okay, I don't know if you can see that, but it looks a little bloated. Okay, so we'll have to replace that. Alright, let me clean this up and then we'll start troubleshooting. Alright, so I got everything all cleaned up here and here. I disconnected everything so we can remove the boards. And so the way this is set up, you got your power supply here. Okay, you got a transformer and bridge rectifier here and your 2 main capacitors for the bigger power rails and then your smaller ones. There's 3 regulators, plus or minus 15, and I think this is a 5 volt regulator. I'll have to check, I'm not sure. So this is your power supply, this is your digital board, and this is your analog audio signal in and out. And this is set up a lot like the 1980s Roland gear that I've looked at. In fact, this is the DRV-2000, and Roland came out with a SRV-2000, which is also a reverb unit, and it's set up the same way. And now the Roland unit is a little more over-engineered than this one. It's a little beefier on the power supply. It's got a lot more caps. It's a better product, I think, than this one. But getting back to this, what I'm going to do is I think I'm going to remove these two capacitors here because there's something there. It may have leaked. One of them may have leaked. I don't know. So I'm going to remove these two for sure, and I'm going to test the other ones. Then we're going to plug it in with everything else disconnected to see if we're getting our voltages on there, okay? And let's start there, and then we'll go from there, okay? All right, before we do anything, let's see if we can get some schematics on it first. All right, guys, I couldn't find a schematic, but I was able to find a owner's manual. So let's see if we can get any information out of here. And I don't think we're going to find any schematics, but we could get like the specifications. Let's see, page 48. So that's at the end. I'm just curious to see how much power this thing draws and what kind of current. Okay, so specifications. Power supply, 117, let's say 120, okay? And 17 watts, okay? So that means 17 divided by 120 volts. It's around 140, say 150 milliamps. So this thing is going to draw 150 milliamps. That's pretty low, okay? That's not bad. Let's see what else can we get out of here. Let's see, it's 16 bits, okay? Distortion, 0.01, 0.05 with the effect on, okay? Frequency characteristics. Oh, now this is interesting here. So the frequency is 20 hertz to 20 kilohertz, okay? But with the effect on, it can only go to 12 kilohertz. So the 3 dB, the cutoff point is 12 kilohertz. So you're going to lose some of that high end with the effects on. And let's see, this came out in, is there a date on here? Yeah, 1986. So I wonder if when they came out, let's see, the DRV-2000 came out in 1988. I wonder if they changed that. Let me see if I can find some specs on that one. All right, so I found a service manual for the DRV-3000, which came out 2 years later in 1988. And this one has the specifications here. Let's see. So it uses a little more power. It uses 25 watts, so it's going to have a higher current. But if you look at the frequency response, this one with the effect, the cutoff is 20 kilohertz. On the DRV-2000, it's 12 kilohertz. So in 1988 with a DRV-3000, they improved the cutoff point to 20 kilohertz. And even the distortion went below 0.01. So it's actually really low here. They still use 16-bit. Yeah, so anyway, yeah, that's the only bad part about this one is it cuts it off at 12 kilohertz. But I bet it still sounds great. All right, let's remove the battery since it's already dead. Okay, battery's out. And let's take out the two capacitors here. Looks like they're leaking. I'm not sure, but I'm going to remove those two anyway. There's one. And they're both out. It looks like there's some dead bugs on it. I don't think it leaked. They're probably just some dead bugs. All right, let's check them and see if they were bad. should be 220 microfarad. Okay, let's see what we got. 176.7 ESR. Let's check the other one. 183.7 ESR. So that's not too bad. They're within their 20%. They're on the low side, but they're within the 20% tolerance. So let's check the rest of them. $176 microfarad, and that's the other 220 microfarad. Let's check this one right here. Okay, that should have been a 2000 microfarad, so that was close. And this should be a 1000, and it's 860, so that's within 20%. And this one is 869. So the capacitors are all within their tolerance. So I don't think that's what caused this to fail. Let's check some diodes and see how they are. Okay, that looks good. That one's good. Okay. It's moving up and down a little because of the capacitors. That's good. And this one appears to be good. So diodes are fine. At this point, I'm just hoping it's not the transformer. We know the transformer is not shorted because the fuses would have been blown. But it could be open. So let's hope not. All right, I winded up taking out this one also. So I got 3 that I'm going to replace. It was just too low for my liking. And I'm going to replace them with these right here. These are brand new, and let's see what brand are these. These are United Chemicon. 220 microfarads, same as the ones we are replacing. All right, let's measure them to make sure they're good. Okay, 217 microfarads. That one's good. Okay. Let's check the next one. 214 with 0.4 ESR. That's good. And 212.8 with 0.4 ESR. So these will work just fine. Alright, I got the transformer plugged into the board. Got it isolated with a piece of paper. And I'm going to try not to kill myself here. What we're going to do is I'm going to turn it on. We're going to measure the output of the transformer. Okay? And then we're going to go right to the regulators and see what the voltage is. Okay. So, power is on right now, so I should be getting 120 volts AC right here. And I am 125 volts AC. Okay? So let's see what we're getting out of the transformer. So the blue wire is one winding, 11.42 volts, okay? And then the green wire, there's 2 green wires and a black, so that's a center tap. So from one green to the black, from each green to the black, we should have the same voltage. So let's see what that is. 21 volts and 21 volts. So we should have around 42 across both greens. There we go, 42. Okay, so the transformer is working. That's good news. Now we're going to go right to the regulators and see what's going on. Okay, so we have a 5-volt regulator right there, negative 15 and positive 15. Okay, let's start with the 5-volt regulator. All right. Okay, so going in to the 5-volt regulator, we have 14 volts. So that's coming out of the blue. Okay, what did we have at the blue? We had 11. So it's actually 14 because it's being rectified. Okay, so you have AC, 11 volts AC. So by the time it gets there, it's going to actually go up because you have to multiply by 1.4 by the time it goes to the input of the regulator, and then it's going to have a couple of 0.7 volt diode drops. So it's going to be around 14, and that's what we got going in. Okay, so we got 14 volts going in. Oop. Right. Let's see what we got coming out. We should have 5 volts. And we don't. 1.7. See that? That 5-volt regulator is bad. All right. That's the first thing. Let's check the negative regulator. This is negative 15. So I got to try to get in here without electrocuting myself. Actually, yeah, that's not. This one's a little different. It's got to go right there. Oh, sparks. Let me try to get into this negative 15 without electrocuting myself here. Okay, 14. Okay, so that one's good. Let's check this one. This is positive 15. So I've got my 28 volts going in. Okay, I should have 15 coming out. Let's see. And I don't. Got 1.5. Okay, 1.5 coming out. So that's bad. That's bad. The negative 15 regulator is good. This middle one, the 5-volt regulator is bad, and the 15-volt regulator is bad. So that's what's wrong with this power supply. All right, I put in the 2 regulators and reconnected all the circuit boards, and everything is back in.
I installed a coin cell Duracell battery, brand new. I even put in a battery holder so you can just push the tab right here and the battery will just pop right out in case you need to replace it. Okay, you just pop it right out like that and put a new one in. All right, now the purpose of this battery is in case you unplug the unit, okay, you don't want to lose your programs. Your programs go in this static RAM chip right here, and that's volatile memory. So if you ever unplug it, you're going to lose all that stuff. Okay, so the battery is there to retain that those settings that you put in there, so it'll provide power to that static RAM. All right, I've got the unit unplugged. Let's see if the static RAM is getting 3 volts from the battery. Okay, and it's getting 2.904. So it's working, and it will retain your program settings.
Okay, everything is plugged in, and I'm plugged into my amp. And I got my guitar. And here we go. Nothing yet. Oh, there's the number. And oh, okay, I see. Let me see. I don't know if you can see that, but it's on. But there's no backlight. Okay, so that's another issue. Let's see if it works. All right. Level works. Effect mix works. Channels work. Flanger. It's got a flanger too. I didn't know that. And a chorus. All right, so it's working, and there's no backlight. The LCD works. Here, let me get in closer. So you can see the LCD is working, but there's no backlight.
All right, guys. So this right here is where the power goes to the backlight, that connector. And I don't know if you can see, but right in there, let me try to get a good shot. Right there, that's where it connects to the LCD. Okay, and then these cables here are the data cables, and they go right over there. Okay, so what I think I'm gonna do is measure right here that connector to see what kind of voltage we got coming out of there, and if any voltage is even coming out. All right, let's turn on the power and measure the backlight connector to see what kind of voltage we have right here. Okay, this connector right here. Okay, so let's see. We have negative 2.15 DC. Okay, let me switch the leads around. Let's see here. Oh, it's still negative 2.2. Okay, so I think we have an AC voltage here. Let me switch to AC and let's see what we got. Wow, 125 volts AC. Look at that. Let's check the other way around. Yep, 125 volts. So this is not an LED backlight. All right, so this is probably a CCFL backlight or incandescent backlight because the connector is producing 125 volts AC. All right, and here's a transformer right there. So I think what you have here is an inverter circuit going into the transformer and stepping up the voltage to 125 volts AC for the light. So we're not going to be able to replace this this backlight because it's not a LED backlight. All right, I searched online and this is the only place selling a Korg DRV-2000 backlight. And they want $67.10. So after shipping and taxes, it's going to be around $80. So at this time, I don't think we're going to fix this. But it does work. And you can see the LCD display if you look at it, you know, straight ahead. It's just going to be without a backlight. So anyway, we're going to leave it here. So thanks for watching and catch you next time.